Now, this time, the ball does not lie on the ground or on the table. I'm holding the ball and I'm going to throw the ball. Okay, now I'm going to throw this ball horizontally at a speed of let's say 3 meters per second. Okay, so 3 meters per second, and so therefore this ball starts flying out. Okay, and it starts falling because of its weight. Okay, so that's where we are. Now I want to find the velocity of this ball, say after a time. After let me say maybe half a second. Okay, after half a second, I want to know the velocity of this ball. I want to know the speed and I want to know the direction. Okay, how do we do this? And suppose that we are also given that the weight of the ball. Let's say I'm also given the weight of the ball, that it is maybe 5 newtons. Given that it's 5 newtons, and that its mass, okay, that its mass is 0.5 kilograms. Suppose that we are given this information, right? What is the velocity after half a second? Okay, how do we do this? Well, let's think about the connection between velocity and mass and force and time. Let's write down what we have. We have that force is equal to ma, F equals to ma, or if I write it directly in terms of the velocities, it will be mass times final minus initial velocity divided by time taken. Okay, now this time is a bit more complicated than motion along a straight line. With motion in 2 dimensions, the velocity changes direction. So what should we do? Now remember what happens when there is direction. For v minus u, we must think of v and u as vectors. So it's vector minus vector, and the answer, well, after you divide by t and m times m, the force is also a vector. It also has direction, and we have already learned that because of this equation, this change in velocity, final minus initial velocity, this change in velocity is also a vector, and the change in velocity vector must be in the same direction as the force. Now in this case, the force is downwards. This is the force, right? That's our force, 5 Newton, and it's downwards. Now let me draw this, let me try and find this v minus u. Let's see, v is here. That is, this is v, right? This is v. This is my vector, v, and the vector u is this one. This is u vector. Okay, u is pointing horizontally, v is pointing at this angle. So how would I find the difference, the v minus u? How would I find that? Well, I would use the vector triangle method. I would imagine moving these two vectors. I'm just going to move this vector. Imagine as an arrow. I'll move it to here. Right? Remember that I must keep the same direction. I'll move it until here so that its tail touches the tail of v. And once I've formed this, I can then complete a triangle with those two as the sides by joining the tips of the arrow, and this actually gives me the change, gives me the v minus u. Okay, so this is actually vector v minus vector u. So a bit mathematical at this point, but think of it as a set of rules we have to follow when we use this equation. So the important result here is that this direction, alright, this is the change in velocity, and its direction has to be the same as the direction of the force. Right. Okay. Now let's see what we have so far, and what we have and what we need. Now this is a right angle because u is horizontal, and the change in velocity is in the same direction as the force, which as the weight, which is vertical. So horizontal, vertical, angle between them is 90 degrees. Now v is what we need to find, and when we say we need to find the final velocity v, it means that we need its magnitude, which is the length here, and we need the angle. So we need the angle theta. This out, we need the angle theta. And we need the magnitude of the final velocity. I'll just call it v. Right, represented by this side of the right angled triangle. Now, if we can find out a bit more about this right angled triangle, we might even solve it using some mathematics. What do we know about the sides of the triangle? U has a length of 3. All right, well, it's meters per second. It's not really length. Okay, but we treat it as 3 units of length in this triangle. So that's a 3. Now, do we know anything about this side, the change in velocity u? Okay, well, we know the force. We know F. We know m, the mass. That's m. We know t, the time. That's t, which is half. So in principle, we can find the magnitude of v minus u. Alright, the v minus u, we already know is in the same direction as f. Okay, so if we just consider the magnitude, it is the magnitudes that will be multiplied or divided by the m and the t. So this means that since the force is 5 newtons, okay, if I rearrange this, I'll have v minus u. I rearrange this, v minus u, and bring t and m over to the other side. I'll have t over m times f. Now, if I now just consider the magnitude, because I've already understood about this about the direction, right? That v minus u has the same direction as f. Okay, so now I'm just dealing with the magnitude at the moment. I would calculate this as t, which is half, divided by m, which is 0.5, and multiplied by f, which is 5. Okay, and the answer is Now half and 0.5 cancels. I'm left with 5. And since we're talking about velocity, this is 5 meters per second. So where are we? Oh, we are here. So that's the difference, change in velocity. So the magnitude of this change is 5. So that gives us another side of the triangle. So we have a right angle triangle in which we know the two sides next to the right angle. Now this defines, this is all the information we need to solve this triangle for the longest side V and the angle theta. So let's do it. We can find the longest side using Pythagoras theorem. Okay, this means that V should be equal to the square root of 3 squared plus 5 squared. 5 squared plus 3 squared. Okay. Right, using our calculator, we need to find this. So here goes. Here we go. We need square root of 5 squared plus 3 squared. Alright, be careful. Your version of calculator might be different from mine, so you might have to press this differently. So anyway, in this case, in my case, this is what I get, 5.83. I'll just take it as 5.83. So we'll write this out. 5.83, and units are meters per second. How about theta? Okay, now I need to know theta. Now theta I can find by considering the 5 and 3. So the tangent of theta is 5 over 3. Okay, so theta will be the inverse tangent of 5 over 3. So inverse tangent tan minus 1 of 5 over 3. Now let me whip out my calculator again. Right. I need the inverse tangent of 5 over 3. $59.03. I'll just take it as 59.0. So therefore, my answer is 59.0 degrees. Alright, remember, even if I put down, I should include the 0, alright, to tell us that it is accurate to 1 decimal place.